Right. Questions on apparent and absolute magnitudes are always tricky. Um, let's first look at what absolute magnitude really means. Um, if you increase the absolute magnitude of a star by 1, its power output decreases by a factor of 2.5. So not only is it the opposite way round, but it's also a logarithmic scale. Now we're told that A produces less light than B. So the first thing we need to do is work out what power of 2.5 that number is, 0.1584. Take logs of both sides and rearrange, and you get n equals log of 0.1584 divided by log of 2.5. And therefore the power is minus 2. So that is 2.5 to the power minus 2. So let's just compare that with what we wrote earlier. From A to B, the power, it says that A produces less light, so the power has increased by a factor of 2.5 squared. That means that the magnitude has got less by 2. So the absolute magnitude of star B is minus 4. A is therefore the dim star, B is the bright star. And given that they have the same apparent magnitude, that means A must be closer and B must be further. So which star is further from Earth? The answer is B. Now, by what factor? This is the inverse square law. Remember, we're looking at the apparent magnitude. The brightness is goes like, I suppose, proportional to the power over d squared. So the distance is proportional to the square root here of the power. And therefore, the power ratio is 2.5 squared. That's the ratio of powers. So the distance ratio is just 2.5.